Today's lesson is on understanding functions. Today, we will understand that a function is a rule that assigns to each input exactly one and only one output. The graph of a function is the set of ordered pairs consisting of an input and its corresponding output. The definition of a function is that a function relates each element of a set with exactly one element of another set. If we look in the examples down below, here and here, in the first picture, we do not have a function. We do not have a function because in my inputs, this input is mapping to outputs. But the definition of a function is exactly one output. If we look in picture 2, this input is mapping to one output, and this input is mapping to one output. It's okay that they're both mapping to the same output. Not a function, function. When looking for a function on a graph, we need to see if it will pass the vertical line test. On a graph, the idea of single valued means that no vertical line ever crosses more than one value. If we look at this graph, we can see it does not pass the vertical line test because when the vertical line was drawn, it touches the graph in two different places. In order for it to be a function, it can only cross in one place. Let's look at a couple of the different ways you'll be expected to identify functions this year. Again, we have to remember that in a function, it relates one input, and my input is normally going to be my x values, to exactly one and only one output. So let's look at our first relation, which is a set of ordered pairs. Again, the first thing we want to do is find our inputs. Your inputs are always going to be your x values. In this case, my inputs are 0, 1, 2, 3, and 2. 0 maps to 2, 1 maps to 3, 2 maps to 4, 3 maps to 5, and 2 maps to 6. In this case, we do not have a function because the input 2 appears twice and maps to different outputs. 2 may only map to 4 or to 6, but not both. Again, for each input, there can only be one output. This is not a function. Let's look down here at example 2. In example 2, we have what's called a mapping. In a mapping, we again have our x values and our y values. My inputs are 4, which maps to 4, 6, which maps to 7, 2, which maps to 7, and 8, which maps to 9. This is a function. This is a function because each input maps to only one output. Notice it's okay for an output to be connected to more than one input, but the input can connect to only one output. Think of it like a vending machine. On a vending machine, if you were to press B4, you might get M&Ms. But you can't press B4 and get M&Ms and then press B4 again and get a soda. Okay, that would not be a function. Let's go over to example number 3. This is an example type that you've seen before. A table. In our input-output tables, again, the x values are the input and the y values are the output. So again, we start by looking at our inputs. One good clue is that if your inputs do not repeat, it probably is a function, because if your inputs don't repeat, they can't map to more than one output. In this case, 1 maps to 2, 2 maps to 2, 3 maps to 3, 4 maps to 4, and 5 maps to 5. So yes, this is a function. However, when we look at the table up above, 3 maps to 4, 6 maps to 8, 9 maps to 12, 6 maps to 16, and 3 maps to 20. Here we can see this is not a function because 3 maps to 2 different outputs. 3 maps to 4 and 3 maps to 20. Also, 6 maps to 8 and 6 maps to 16. This is not a function. Again, each input can have exactly one output. 3 cannot map to 4 and 20. 6 cannot map to 8 and 16. The last type of function that you may encounter this year is a graph. When we look at a graph, we have to see if it passes the vertical line test. In this case, our graph is a vertical line. If I draw a vertical line over the top of this vertical line, it would not pass the vertical line test. So this, in essence, would be not a function. If I go back and draw another line, and I use the vertical line, I can see that this line, or it's not really a line, but this graph would be a function because it is only touching the function in one spot. This would be the same case if we looked at another line. So let's erase what we have. We'll use the vertical line that's on there, and let's look at another scenario. So in this scenario, let's say we have a graph that looks like this. This is not a function because the vertical line is touching here and here, which makes it not a function. Let's look at one more. This time, I've drawn a linear function, a line. This is a function because the vertical line is only touching it in one spot. Next, I would like you to take a look at a couple different relations and see if they are functions or not functions. You have examples 1, 2, and 3. For each of these examples, I want you to tell me, is it a function or is it not a function? Here we have another table. We'll call this example 4. Again, I would like you to look at this table and tell me, is it a function or is it not a function? Feel free to rewind and re-listen to the video. Lastly, we have example 5. I would like you to read the problem for example 5 and using the table, decide if this would be a function. The table below shows the number of dog licenses issued in the town of Palmer over a 5-year period. On the blank graph to the right, label and number the axes, then plot the ordered pairs. We are not going to worry about that part. All I would like you to do is look at this table, look at the inputs and outputs, and decide, is this a function? That's it for our lesson on functions. Have a great day.